So my name is Hannah Patterson, and from experiment 5, I'm going to be explaining how to calculate the empirical formula for magnesium oxide. So to start out, we need to find the initial mass of magnesium and the mass added by oxygen. So we have our initial mass of magnesium right here, which is 0.11 gram, and we know that our total mass was 0.19. So in order to find the mass that was added by oxygen, which we need for the empirical formula, you subtract the total mass from your total mass of magnesium, and you end up with your 0.08 grams mass added by oxygen. So the first step in actually calculating, we have our moles of oxygen and our moles of magnesium. Both of these values are going to be what we need to calculate the actual empirical formula. So our moles of oxygen, we have 0.08 grams because that was our mass added by oxygen, times 1 mole divided by the atomic mass of oxygen, which is 15.999 grams. And then after you multiply those 0.08 grams times 1 mole divided by 15.999 grams, we get 5.003 moles, and that takes us to our next step of finding our moles of magnesium. So we take our initial mass of magnesium, which was 0.11 grams, multiply that by 1 mole divided by 24.305 grams, and that gives us our 4.5258 moles. And then our next step is to find the whole number ratio. We have to divide both values by the smaller of the two mole values that we got. So we're going to take magnesium first, and our mole value for magnesium was 4.5258. And since we have to divide by the smaller of the two mole values, we would just end up dividing that value by itself, and that would obviously give us 1. So next we would move to the oxygen. So the molar mass of oxygen was our 5.0003, and we once again are dividing that by the smaller value of the two, so the 4.5258, and that gives us 1.104. So rather than having that 1.104 in our empirical formula, we would obviously round that, and we would end up with MgO as our final empirical formula.